When you press your fingers together, you're applying roughly 1 Newton of force. By contrast, the Coulomb force between a hydrogen nucleus and its electron, it's only 0.00000082 newtons, which is quite small. In other words, as long as the force you apply to them, slightly exceeding this value, you could break a hydrogen atom. But in reality, if you squeeze your fingers hard, during this process, is it possible that even a single atom gets crushed? Or if you take a sharp knife, when you use it to cut vegetables, could it accidentally split some atoms? If you're sitting on a chair, it feels and looks like your butt is touching the seat. But at the atomic level, that's not the case. There's an incredibly tiny atomic gap between them. You're actually floating in the air. Both your butt and the chair are made of atoms, with a nucleus and electrons orbiting around it. When two atoms get close without reacting, their electrons repel each other because they have the same charge, making it hard for them to touch. Thanks to the Pauli exclusion principle, atoms can't be compressed to get closer to each other. When chopping veggies, the knife slices through easily, but it never actually touches the food. It uses the repulsive force of electrons to push apart the atoms in food. So, someone might ask, what if my 2 fingers were really strong? It won't deform under pressure. So, can you crush an atom like this? Objects that don't deform are called rigid bodies. If rigid bodies existed, then the particles making them up would need an infinite force to hold them together. The particles would attract each other and collapse, reducing in volume, until it forms something like a black hole. But this hypothesis is not easy to achieve with current technology. So, how exactly can you break an atom? Bananas are rich in potassium, and roughly 1 in 8,000 potassium atoms is radioactive. If you eat 600 bananas in one go, the radiation you receive is equivalent to getting an X-ray. Some heavier radioactive isotopes can release neutrons. You can use these neutrons to hit other atomic nuclei, effectively breaking atoms. In theory, any atomic nucleus larger than an iron nucleus can undergo nuclear fission. However, this method is not exactly safe. If an uncontrolled chain reaction happens, you'd not only face the agony of an atomic blast but also legal trouble. In 2011, a Swedish man got arrested for splitting atoms in his kitchen with radioactive stuff like radium, coal, and oil. Besides that, there's a relatively simple and safe method. We know that nuclear fusion reactions occur at extremely high temperatures, essentially to speed up particle movement, giving them enough energy to collide. If you could clap your hands at nearly the speed of light, some of the atomic nuclei in your hands would collide to form new elements, releasing a large amount of energy and neutrons. Clapping isn't against International Atomic Energy Agency rules, so feel free to give it a shot.